Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 6A. Myself, Ashutosh Goyal, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GIA Scholastic LLP, it is my great pleasure to welcome you all to the 4th World Conference on Information Systems for Business Management, ISBM 2025, Bangkok, Thailand. The fourth edition of the conference is being organized in a hybrid way. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow. That is 25th and 26th September 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chairs for the session, Dr. Dushyant Singh Rathore and Dr. Ruchi Nanda. Dr. Dushyant Singh Rathore is a professor and head of Department of Computer Engineering at Ahmedabad Institute of Technology. He has over 11 years of teaching experience and 4.2 years of industry experience, bringing together strong academic expertise and practical industry knowledge. Thank you for joining us today, sir. I request you to kindly say a few words of encouragement to our participants.
Hello.
Yes, sir, you're audible.
Yeah, thank you very much. Hello. Am I audible?
Yes.
Thank you very much for inviting me. I'm really grateful to the organizer and Arutosh, you too. So thank you very much once again.
Thanks. Moving on to our next chairperson, Dr. Ruchi Nanda. She's an associate professor and head in the Department of Computer Science and IT at IIS deemed to be University, Jaipur, with 17 years of expertise in teaching and research. Her areas of interest include big data, cloud computing, machine learning, and databases. Thank you for joining us today, ma'am. I request you to kindly say a few words to the participants.
Thank you, Ashutosh and Pat. Am I audible?
Yes, ma'am.
Yes. Thank you, GR team, especially Mr. Amit, for inviting me as a session chair in the prestigious conference that is being held. I wish all the participants uh, a good luck for presenting their research work in such an session. Thank you.
Thank you, ma'am. Now, without further ado, I would like to start with the papers. First, I would like to call upon Ma'am Smita Kalukar to present a paper on the title, A Comprehensive Study on Work-Life Balance of Dual Career Couples. Do we have you here with us, ma'am? Is anyone from the team here with us? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call upon Sir Revu Bhattacharya to present his paper on the title, An Empirical Validation of DevOps Critical Success Factors in Developing Countries. Do we have you here with us, sir?
Yes, can you hear me?
Yes, sir.
Just can you help me just see if you can share my screen? Is my screen visible?
Yes, sir.
Okay, thank you. I'll start my presentation right now. Also, let me turn on my video. Good afternoon, everyone. Thank you for being here. I am Viva Bhattacharjee from Independent University, Bangladesh. And I'm going to present my research paper titled An Empirical Validation of DevOps Critical Success Factors in Developing Countries, conducted by me and my co-authors at Independent University Bangladesh and North South University. So our current study and research is about DevOps and critical success factors. So what is DevOps? DevOps is the latest software development methodology where development and operations are combined to work in parallel to deliver software, various types of software. Critical success factors are the essential practices or elements without which any project would not succeed. So the CSFs in DevOps are basically the essential practices that are absolutely required for DevOps project success. The motivation and behind this research was that in globally we have seen that there was a lot of literature and research done to identify CSFs in the global context, but none done in the context of developing or emerging economies where there are resource constraints or different culture or social factors involved. Also, such current CSF models that have been researched lack empirical validations in the context of developing countries. Hence, we found that was a gap, and this is why that motivated us to do this research. So primarily, we had three research questions. Research question one was, to what extent does DevOps CSF explain variance in project success within developing countries? Which organizational, social, cultural, and technical CSFs are the strongest independent predictors of DevOps success? And how applicable and valid are the existing CSF models in DevOps across organizations in developing countries? All of these research questions were answered by our studies, as will be shown later. So we looked at the related works, and we found that there was a lot of literature, extant literature done on the critical success factors in DevOps, but most were literature reviews and decision-making frameworks, not empirically validated models. One research in particular done by Nasrin Azad and Sami from Lodz University, they did the most comprehensive systematic literature review on this topic and proposed a model. So our study is exploratory and confirmatory, and it does an analysis based on their research. We have taken inspiration from their data and research. Also, we have collected data on our own. So our research method, we have done primary data collection, and primary data collection involved a quantitative cross-sectional online survey distributed through professional networks, and ultimately 23 DevOps professionals in Bangladesh filled out our survey. And the survey consisted of various demographic, organizational, social, cultural, or technical questions. So you can see like there were different types of DevOps engineers that self-identified as like senior, lead DevOps, or normal DevOps engineer. Some self-identified as cloud engineers or software engineers, but that was sort of less. 70%, since 70% was 70% of them self-identified as DevOps engineers. The structure of the questionnaire, just very briefly, was we had 7 demographic questions, 4 questions involving organizational factors, 4 questions involving social and cultural factors, and 12 questions involving technical success factors, and 1 open-ended question where they could write anything else that was required from their perspective. So the results of the questionnaire, we analyzed the data using Microsoft Excel, and we did various statistical tests to confirm and explore certain hypotheses. So one of the first statistical analysis that we did was that we did a multiple linear regression analysis with n equals to with a sample size of 23 and a sample size of 23 with like 19 dependent variables. We found out after the analysis that there was a high coefficient of determination of 0.956, although when adjusted, it became lower because of a little bit of overfitting since we had so many dependent factors. But however, we saw that there was also low mean square error, and there was barely any multicollinearity observed. So we found that result to be significant at the significance level of 0.20, since this was primarily an exploratory study. So that proved that our multiple regression was valid. Furthermore, we did various hypothesis testings and did t-tests and found out that only 5 different coefficients out of the 19 were significant at the 0.20 level. This was probably due to a lack because of the low sample size and the exploratory nature of the study, and the fact that the different critical success factors do not independently predict project success. However, we could standardize our coefficients and rank and cluster them into broad categories such as performance engineering, integration, build test, automation, etc. And we could rank all these broad categories. We could rank all these broad categories and ergo see which one is more important than the other, since that is the purpose of ranking. This was another finding. So according to our rankings, what we could do was that we proposed a model, and the idea. So this model was initially developed by Nasrin Azad and Samihir Silami, but however, they did not do an empirical validation. What we have done here is done an empirical validation to confirm whether this model is valid in our context. Since our project, since we saw that our square values and the other values and the multiple regression was fairly valid, we figured that we saw that so hence we proposed this model where each arrow is represented by the rank of their the rank of each success factor is represented by the thickness of each arrow. As you can see, inter-organizational collaboration ranked the highest, hence it has the highest, since it has the thickest arrow. And DevOps as a service has the lowest rank, hence it's the least important, hence the arrow is the thinnest. So this was our proposed model. Of course, our study had limitations. Firstly, obviously, we had a small sample size. Therefore, we would suggest that more multi-regional samples and bigger sample sizes be done for confirm this model. Furthermore, it must be noted that our study was not controlled. For example, different organizations within the same country or within the same society might have different organizational cultures and let's say different DevOps maturity models. So further studies need to be done in a more controlled setting. And yes, we had a we did a quantitative study, hence we would suggest that further studies be done qualitatively and more case studies be done, and so that the relationships can be explored more deeply between CSFs and DevOps. So as you can see, our study addressed our research questions. DevOps CSF explained approximately 68% of variance in project success. This is the R-square adjusted value. We found that no CSF can independently predict project success. And the importance, as you have seen, of each CSF was determined. And we have seen from the regression analysis and the least squares estimators that the CSF model is somewhat applicable and valid across different organizations in our developing countries context. So yes, so this study ultimately provides a valuable insight into the context of developing countries, but the results should be interpreted with caution and shouldn't be generalized due to the smaller sample size. So yeah, we want to thank all our research participants and Nasrin Azad and Sami Hirsulami for their research. That will be all from me. Thank you.
Thank you for your presentation, sir. Are there any questions?
Very nice presentation. All the things are clear. I just have a question. How you validated your survey form?
We validated
Is
our
it a
survey form. I'm sorry, go on.
yes, how you validated it? Is it from a standard source or?
So we sent out a questionnaire that had like 19, as I've said, 19 different questions with like 10 they were mostly Likert scale questions. So let's say we would ask them, we would ask the employees, the DevOps engineers of any software firm, the software firm, that how much do you agree that this performance engineering practice leads to DevOps success, or how much do you disagree, right? So that there's no lead on bias or anything.
Right.
So this is how we collected the data from various different organizations and various different employees of these organizations.
Okay. Okay, that's a question from my side. All the best.
Thank you, ma'am. Are there any other questions?
Hello.
Yes, sir.
Okay. Fine. You used DevOps and everything in your area, but have you think about the machine learning and DevOps that you have to use in your like software or in a real-time
Okay,
application?
sir. So there is a correlation, or people do use machine learning and deep learning and all of that in DevOps practices these days, but it is a further step, let's say, because since I've clearly mentioned that the critical success factors of DevOps in our context hasn't exactly been identified and validated yet. So implementing or using machine learning in DevOps is probably a further step, if I'm not mistaken. So once we've done this research, and maybe once we have comprehensively done this research, maybe later we can we can research more about the use of machine learning and deep learning and all of that in DevOps methodology. Does that answer your question?
Okay, fine. Good enough.
Thanks, sir. Moving on to the next presenter. I would like to call upon Ma'am Camila Nicole Fernandez Morocho to present her paper on the title Feasibility Analysis for the Construction of Civil Works in the Western Zone of City of Loja, based on the bearing capacity of its soils. Do we have you here with us, ma'am? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call upon Sir Grant Roy Howard to present his paper on the title Oversight of Autonomous Organizational Systems, AOS, Decision Making. Do we have you here with us, sir?
Thank you, Chair. I'm going to share my screen.
Yes, sir.
And welcome to my presentation. I'm, sorry, 1 second. Okay, I just need to make this smaller. Okay, great. So good afternoon. Welcome to my presentation titled Oversight of Autonomous Organizational Systems Decision Making. I am the presenter and the author, Grant Howard, and I'm from the University of South Africa, UNISA. So what is the study about? It's about artificial intelligence presenting opportunities for non-human decision-making in organizations across industries, creating autonomous organizational systems, or AOS, as I've shortened the name in my study. What is the study? Hang on a sec. Let me see. Yes, so to continue, especially it's the oversight of AOS that is critical, because it is essential that these systems are ethical, safe, explainable, reliable, robust, fair, unbiased, compliant, responsible, and trustworthy, which is a long list of important aspects that these systems have to cater for. So why is this knowledge important? Knowledge about the oversight of these systems is important for all AOS and related AI scientists, academics, researchers, programmers, and organizations. And it's important because to ensure improved conceptualization, development, deployment, maintenance, usage, and evaluation of these systems. And this is for the betterment of and prevention of harm to humanity. Excuse me, there we go. Oversight, just to summarize what I'm trying to say, is oversight is an indispensable obligation in every life cycle activity of AOS and related AI systems. So it's something we really can't ignore as scientists, AI developers, and organizations and users of these systems. So what are the real world problems that the study is addressing? These include biases in algorithms and data, obscured accountability and legal liability, ethical ambiguity and conflicts with human values, black box decisions and unpredictable behavior, security and privacy vulnerabilities, system failures, errors, and integration challenges, loss of human control, outdated legal and governance frameworks, regulations, and industry standards, and reputational damage, financial and competitive losses. Now moving to the research problem for the study in terms of a knowledge problem. So although human decision-making oversight literature is extensive across many disciplines, little exists about AOS decision-making oversight. So this was the knowledge gap and the research problem for the study. Why is this significant? The lack of this knowledge exacerbates these real-world problems. So what was the study's solution? The study's solution was to produce AOS decision-making knowledge in the form of an original conceptual framework, exposing the fundamental oversight concepts, and these to guide scientists, researchers, programmers, and organizations in their oversight during every life cycle activity of AOS and related AI systems, and therefore to mitigate the real-world problems. So the study's methodology, a conceptual research design was applied to answer the research question, being what fundamental concepts are essential for AOS decision-making oversight. The conceptual research methodology was appropriate because the objective was to use analysis, synthesis, abstraction, evaluation, and reasoning to develop the framework. Now, conceptual research, with rationalism being the epistemological underpinning, is also reported to be one of the top 3 research types in information systems research. So this is the result of the research, the conceptual framework. These are the concepts, the fundamental concepts. They are governance framework, delegation and autonomy, human involvement, transparency, traceability and explainability, accountability, ethical and legal compliance, risk management, and then feedback, adaptation, and improvement. So I'll elaborate on each of these concepts briefly. Governance frameworks are imperative for oversight since they provide the authority and direction for oversight. Then delegation and autonomy are important for assessing the potential for unintended consequences. Human involvement is essential, and that's to ensure AOS alignment with human values, ethics, norms, laws, and objectives. Transparency, traceability, and explainability are indispensable for the visibility of decision-making processes, the auditability of data and decision steps, and the understandability of decisions. Accountability is crucial for the attribution of both fault and credit. Ethical and legal compliance are central to protect stakeholders from harm and to build trust. And legal non-compliance may result in penalties, lawsuits, and reputational damage. Risk management is essential to mitigate potential harm and promote safety, ethics, and compliance. And feedback, adaptation, and improvement are required for oversight bodies to remain relevant and effective over time. So this framework matters to all stakeholders of AOS and related AI because these fundamental concepts are essential for building and deploying these systems so that they contribute positively to humanity, they are safe, ethical, and they comply with laws and regulations. By developing this framework, the study makes an important contribution to knowledge relating to oversight and governance of AOS decision-making. This is to guide scientists and technologists in the era of AOS and related AI to progress and safeguard humanity. So the limitations of the study, of course, the lack of empirical data for validating the framework in practice is a limitation, but this presents opportunities for future research. And this can include empirical data through expert reviews, the Delphi method for expert consensus, case studies in various organizations and industries, surveys for evaluating perceptions of individuals, even simulation and scenario testing to expose AOS behavior under different conditions. Then, of course, future research could involve various organization types and industries to investigate the level of each framework concept, the implications of the different levels for oversight, and the level thresholds that either progress or threaten humanity. So thank you for taking the time to attend the presentation. I wish you all the best for the rest of the conference, and I'm happy to answer any questions. Thank you.
Thanks for your presentation, sir. Are there any questions?
So is it a part of your research? Is there
Yes.
a part of some research project? Are you?
Yes, it's the beginning of research projects on AI
Okay.
ethics and autonomous systems ethics and oversight. So it provides
So
a
how are you?
foundation. Yes.
Okay, so how you are planning to basically implement this thing?
Well, I haven't got any plans at the moment to implement. I think the next stage for me would be to start gathering empirical data to
Yeah.
validate the framework and to understand what concepts are used and applied differently across various industries and organizations, and then to provide recommendations on where improvement should happen for improved oversight and governance.
Yes, because in these type of topics, recommendations are also equally important.
Yes.
Yes, yes. Okay, thank you. All the best, sir.
Thank you.
Thank you, ma'am. Are there any other questions?
Hello.
Yes, sir.
Yes, sir. Sir, nice presentation. But I'm having just only one question. Which decision is better? Okay, by using robot or manual?
It depends on the application, and I think it depends on the context as well. So in some contexts, it might be there might be good reasons to employ humans to do the job, either for the preference of the job or for supporting human employment. And in some situations, it might be better to have a robot. I think the worry is that as we move into the future, especially with AI evolving so quickly, it seems that it might be more profitable to remove people and use robots and to use AI, which is a great worry, I think, for everyone, including academics. But perhaps there will be a balance, and we will work in collaboration and increase our productivity with these systems as opposed to being replaced entirely.
Robot is better, but they are grabbing the jobs of humans.
Yeah.
Okay, fine.
Yes,
Okay, fine. I'm done.
okay. Thank you, sir.
Thanks for your presentation, sir. Now
Thank you.
moving on to our next presenter. Next, I would like to call upon Sir Shubham Kishore Kadam to present his paper on the title Quantum Computing and Behavioral Analytics in HR, the Next Frontier in Talent Management. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call upon Ma'am Priyanka Patel to present her paper on the title The Role of DEI Strategies in Organizational Management and Performance Enhancement. Do we have you here with us, ma'am? There's no response. We'll be moving forward with the next presenter. Next, I would like to call upon Sir Anurag Agarwal to present his paper on the title Towards Smarter Diagnosis, a survey on CNN-based hybrid models in breast cancer detection. Do we have you here with us, sir? Since there's no response, we will move forward with the next presenter. Next, I would like to call upon Sir Angit B. Kuriakose to present his paper on the title Using Cognitivist Theory of Effect Learning, and Engagement in Higher Education, a process controlled engineering case study. Do we have you here with us, sir?
Yes, I'm here.
Yes, sir. You may start presenting your screen, sir.
Thank you. Just gonna open my screen now. I'm gonna put it into full screen mode. Right. Thank you. I hope I'm audible.
Yes, sir.
Right. So I'll go ahead. The title has already been introduced. This is the table of contents for the discussion today. Learning is a very complicated process that is often influenced not only by psychological factors, but also by social dynamics. So in saying that, psychological learning theories tend to study learning by looking at mental processes, while sociological theories focus on the way learning is influenced by cultural and social structures. Combined, they provide a very good perspective on learning and development. So some of the psychological learning theories that we have, they get us to process and retain knowledge. Some of those include behaviorism, cognitive approaches, and we have studies from several advanced theorists such as Piaget and Brunner, as well as Vygotsky, who's given us the zone of proximal development in terms of psychological theories. When it comes to social learning theories, there are functionalism, which was put forward by Parsons, as well as conflict theory, which was put forward by Marx, which ensures that education reproduces social inequality. You also have others, such as the pedagogy of the oppressed, that is put forward by Ferrer, which advocates for an education that encourages reflection and empowers oppressed people. Coming to what we are focusing on, we're looking at the cognitivist learning theory, which deals with memory, thinking, processing information, and problem solving. And in contrast to behaviorism, cognitivism studies how the mind learns, organizes, stores, and retrieves knowledge. And Piaget placed learners at the center of the curriculum planning. He developed the idea of schema, where mental structures that help the organization and interpretation of information. Going forward, Vygotsky stressed the importance of social and cultural contexts in learning. This is where Vygotsky and Piaget kind of differed. His theory on zone of proximal development is the distance between the learner who can do it by themselves and what they can do with the help of a more knowledgeable peer or an adult. So while Piaget emphasized the development of thinking by each learner alone, Vygotsky stressed that the role of social interaction, language, and culture context in learning. So this is very important when we consider teaching and learning from a South African perspective. And that is why that has been brought into the picture here. I'm sure when you're listening in, you can see if it indeed relates with your country of origin and whether it can be adopted in the same setting. So in addition to cognitive theory, we are linking chunking theory. This was developed by George Miller, where he proposed that humans can hold at a time roughly 7 plus or minus 2 chunks of information. Later, Johnson expanded on this with 4 key processes, which are chunk, memory code, decode, and recode, where learners break down, process, and reconstruct information for better understanding. So this case study that we're presenting here is on a final year engineering module called process control. It is a very complex module, as most of you who have done the subject would know, and it builds on previous knowledge of mathematics and electronic courses. Our focus is on one specific element, which is the Routh-Howritz criterion, one of the stability measurement techniques. And the key learning challenges or learning knots that I identified with the students was that they had struggles in retaining knowledge from the previous maths and electronics subjects. There was a time constraint. It's a semester-based subject where all these modules are compressed into 12 weeks, and Routh-Howritz criterion is one part that needs to be well meted out in this 12-week cycle. And there is complex integration. There is need to sympathize or synthesize rather multiple mathematical concepts to ensure that knowledge is received. So what did we do? We put together a flow chart. You can see here, this is integrated with Blackboard or Moodle, as you'd call it in other places as well, where it would be almost like a self-study assistant. So obviously you'll have done the problem or done the criterion in class, but once the students struggle, you'll see that they need to go back and develop it. So here, the yellow blocks highlight the specific learning outcomes. The green blocks present the steps that are required to achieve these outcomes. The red blocks identify the possible learning knots, and the light blue blocks that are to the right of the screen actually give pointers. So it is uploaded on Moodle or on Blackboard, and students can then access notes or videos pertaining to each of these learning notes so that they can go back and at their own time can understand and estimate the data. On the left-hand side, I've included a section which is in dark blue blocks. This is something that we plan to do in future, where we want to introduce a gamification element to this study as well. So the study design, a comparative study was done to evaluate the effectiveness of chunking strategy in teaching Routh-Howritz criterion. There were 300 participants, that is the size of the class. So they were split into two, 150 each in the control group and the test group, where the test group is the one that would be having the chunking strategy as an intervention. There were 5 tutorial assessments on the Routh-Howritz criterion that were tested, and these were the findings. On the right of the screen, you have a red and a blue bar, where the red indicates the control group and the blue indicates the test group with the intervention. So what were the key findings? So we could see that there was consistent outperforming of the chunking intervention or the test group on all 5 tutorials. On average, there was a 9% improvement in that test group, and a structured approach of breaking down complex concepts into manageable chunks demonstrated measurable benefits for a student comprehension and performance. So to discuss, the results suggest that a chunking-based strategy based on the cognitives theory effectively addresses learning challenges in process control. It reduces the cognitive load, and it helped students to connect with new information for previously learned concepts. And like I mentioned, there was a 9% improvement across all difficulty levels. So the theoretical alignment, Miller's 7 plus minus 2 chunks of information for optimal processing, Oswell's meaningful learning theory through connecting to prior knowledge, as well as cognitive load theory by minimizing irrelevant load, and Vygotsky's scaffolding through the structured learning steps all came into the theoretical alignment. So, conclusion, cognitives theory, in particularly chunking, proved an effective improvement student performance in complex engineering education. And breaking down a concept like the Ruth-Hauritz criterion into manageable chunks reduced the load considerably for the students. Then going on, broader implications and future work. The structured knowledge segmentation can be applied to other complex subjects within engineering or other disciplines. The cognitive load management should be a key consideration when teaching complex technical concepts. And like I mentioned earlier, integration of gamification elements could further enhance the engagement and motivation of the students. These are some of my references, and thank you very much for your time. Sorry, allow me to turn on my video to know that it is not an AI person like Dr. Howard was pointing to. It is indeed a human. I'm ready for questions.
How you will take it for what for curriculum development?
Right. Thank you very much, Dr. Nanda, for the question. So as far as curriculum development is concerned, at the university, and I think in most universities in South Africa, we are currently looking at ways in which the curriculum can be redesigned and recontextualized so as to bring in a decolonizing element into it. And one part of this is to try and see how we can manage the cognitive load on the students. And this is one small step in that direction, where we are looking at one element of a subject and looking at how the cognitive load can be minimized. And like mentioned in the presentation, there are options for us to scale this onto my own subject in other sections of the subject, as well as to other subjects within the engineering discipline, and maybe even more. So we're looking at ways in which cognitive load can be reduced, and that is the main focus here. I hope I've answered that question, Doctor.
Yes.
Thank you.
Thank you.
Do we have any other questions? Since there are no questions, we'll move forward with the next presenter. Thank you for your presentation, sir.
Thank you very much, and all the best to all the participants.
Thanks. Next, I would like to call upon Ma'am Lakshmi Ara to present a paper on the title YOLO Assisted SAM, a two-stage deep learning framework for automated PCB defect detection and segmentation. Do we have you here with us, ma'am?
Yes, good afternoon, everybody.
Good afternoon.
I hope I'm audible. Shall I start?
Yes, ma'am, you're audible. You may start the presentation.
Thank you. So, a very good afternoon, everyone. Thank you for being here. Today, I'll be presenting our research titled YOLO Assisted SAM, a two-stage deep learning framework for automated PCB defect detection and segmentation. So, this work was carried out as a collaborative effort at the Amartya School of Engineering, Coimbatore. So, the motivation behind this work comes from a very practical industrial need, that is, a reliable and automated inspection of printed circuit boards. As all of us know, PCBs are the backbone of electronic devices. If they fail, the entire device fails. So, our project attempts to bridge the gap between existing manual inspection techniques and the growing demand for AI driven automation using the latest advances in deep learning. So, our objective. The objective of our study was to design a two-stage deep learning pipeline that could accurately identify and segment PCB defects. In the first stage, we used YOLO V8, which stands for You Only Look Once. It is a state-of-the-art object detection model known for its speed and accuracy. The second stage uses SAM, the Segment Anything model, a recent breakthrough from Meta AI. SAM is a universal segmentation model that can segment any object if provided with the right prompts. So our key idea is simple but powerful, which is YOLO provides bounding boxes and SAM uses them as prompts to generate precise segmentation masks. So instead of just detecting that a defect exists, our model shows exactly where and how big the defect is. So which is far more useful for industrial applications. So coming to the proposed model overview, there are two stages. In stage one, the input is a PCB image to YOLO model. Here, YOLO processes it, identifies suspicious regions, and marks them with bounding boxes. In stage two, SAM takes those bounding boxes and produces pixel-level segmentation masks. This combination enhances the strengths of both the models, YOLO's global detection with SAM's fine-grained segmentation. So here is the model workflow. In the first step, we pre-process PCB images. We used techniques such as to resize, normalize, and annotate. Then YOLO V8 detects bounding boxes for defects. Then bounding boxes passed as prompts to SAM. Then SAM generates segmentation masks for precise defect boundaries. So our final output will be after SAM, that is defect classification plus pixel level segmentation. Hope this workflow is clear from the above figure 2. So moving on to dataset description, we used the OpenLab PCB dataset from Peking University available on Kaggle. It contains 1,386 high-resolution images. There are 6 defect types, that is missing hole, mouse bite, open circuit, short, spur, and spurious copper. The dataset is balanced across these classes. So why does this matter? Because if one defect type dominates, the model will get biased and may ignore the minority classes. So a balanced dataset ensures fair learning. Also, these are real manufacturing images, which means they reflect the variability we would expect in real life practice. So data pre-processing. Data pre-processing was a major step before training. So first we checked annotation integrity for ensuring labels match with the correct images of the respective classes. So this step removes mismatched or duplicate files. Next, we applied data augmentation, such as geometric augmentations, which include horizontal flips, rotations, and random cropping. Also, we did photometric augmentation, such as brightness adjustment, contrast tweaking, and color saturation changes. Then finally, we split the dataset into 70% for training, 15% for validation, and the balance 15% for testing. This is a standard split that ensures enough data for learning while keeping unseen data for evaluation. So next are deep learning models. Let me now explain the models we used, that is first YOLO and SAM. So this proposed system deploys both the models that are optimized to perform different tasks in the pipeline. SAM with the VIT-H, that is the Vision Transformer Huge variant, known for its high accuracy and strong generalization capabilities, is deployed for segmentation, while YOLO V8 is intended for object detection. By combining YOLO with SAM, we exploit the best of both the worlds, that is speed, accuracy, and flexibility. Coming to results and discussion, here I would like to tell that first we did our observations using only SAM, then we checked the YOLO and we integrated both. So first we'll see the performance of SAM. Here we first tried SAM alone to see how it performs for the data. The results were disappointing because the IOU and DIE scores were very low. You could see that in the picture. Some of the defects of the missing hole regions was failed to highlight by SAM. So why? Because SAM without prompts doesn't know where to focus. On PCB, defects are often very small and subtle compared to the rest of the board. So here SAM is not the only SAM is not reliable for precise defect detection. That's why we checked using YOLO. So the solution was to integrate SAM with YOLO. So to address SAM's limitation, we brought in YOLO. Here's how the pipeline works. YOLO detects and localizes defects. The bounding boxes from YOLO serve as a prompt for SAM. SAM then segments only inside those regions. So we trained this combined model for 100 epochs. The training took just approximately 2.6 hours on GPU with memory usage of 4.8 GB. So here we'll see the performance of YOLO model. Performance evaluated via confusion matrix, recall, precision, and FN score. So these were calculated at IOU threshold of 0.5 and is analyzed to evaluate the performance of YOLO model. So this figure shows the confusion matrix for YOLO model. From the previous table, we calculated key metrics and got mean average precision values for precision as 0.97, recall as 0.93, and FN score as 0.95. Also, we got the false negative rates for all the 6 classes, which is listed. So in the below picture, you could see how YOLO model responds to detect missing holes defect. That is, if you go to the SAM model, there was some regions which was not explicitly shown by SAM alone. But here, the same picture, we see that is YOLO shows it as boxes. So next, performance of YOLO SAM model. SAM is then integrated with YOLO. The YOLO SAM is trained, validated, and tested with the dataset generated. The segmentation performance of SAM is evaluated using IOU and DIE scores to measure the overlap between predicted and ground truth marks. The IOU and DICE values are as follows. This for all the 6 classes. So the average IOU was 0.8628 and average DICE score was 0.92. Next, also, we did cross validation and results were consistent across folds, providing a robustness. So this is essential because in real world deployment, you don't want a model that work well only on a subset of data. So our results were consistent across folds. Next, the response of YOLO SAM. Here, the picture shows all 6 defect classes. So this is the qualitative results. You can see 6 examples, one for each defect type. So missing hole, mouse bite, and all the 6 defects. The segmentation boundaries are very precise. This is important because in a production line, we need to know that a defect exists, along with how big it is, where it is located, and whether it will impact the circuit. So our results demonstrate that YOLO SAM model can be used as a practical inspection tool. So to conclude, I'll summarize our contributions. That is, standalone SAM fails in PCB defect detection due to lack of guidance. So integrating YOLO with SAM provides a precise bounding boxes, enabling SAM to perform much better. The combined YOLO SAM pipeline achieves high recall, precision, FN score, IOU, and DICE values as shown in previous slides. So it is significantly reducing false negatives compared to SAM alone. So hence the proposed architecture can serve as a robust and efficient solution for automated printed circuit boards inspection in real-world industrial applications. So the future directions could be to optimize computational efficiency while maintaining accuracy. So these are the references we used. So thank you very much for your attention. This concludes my presentation on YOLO SAM framework for automated PCB defect detection and segmentation. Thank you.
Thanks for your presentation, ma'am. Do we have any questions?
No questions from my side. She has given a very comprehensive presentation. Thank you so much.
Thank you, ma'am.
Do we have any other questions from anyone else? Since there are no questions, we'll be moving forward with the session. Next, I would like to call again Ma'am Smita Kalukar to present a paper on the title, A Comprehensive Study on Work-Life Balance of Dual Career Couples. Do we have you here with us, ma'am? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call again Ma'am Camilla Nicole Fernandez Morocho to present her paper on the title, Feasibility Analysis for the Construction of Civil Works in the Western Zone of the City of Loja, based on bearing capacity of its soils. Do we have you here with us, ma'am? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the next presenter. Next, I would like to call again Sir Shubham Kishore Kadam to present his paper on the title, Quantum Computing and Behavioral Analytics in HR, the Next Frontier in Talent Management. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we'll move forward with the next presenter. Next, I would like to call again Ma'am Priyanka Patel to present her paper on the title, The Role of DEI Strategies in Organizational Management and Performance Enhancement. Do we have you here with us, ma'am?
She is not present, but the co-author Priyanshi Desai is present, and I would like to present the paper.
Sure, ma'am. You may start your presentation, ma'am.
Yeah, thank you. Hello and good afternoon, everyone. My topic is the role of DEI strategy in organization management and performance enhancement. To work with this topic, there was many things I have watched in the corporate works and the everyone else in the business strategies and everything. So it was like DEI full form is diversity, equality, and inclusion. It provides the vital modern business success, the strong finance performance, empowerment for everyone, for like employees, creating productivity and inclusive workplaces. It leads to the higher profitable market reach and creativity. Challenges are many, like the gender stuff, the equality of people and everything. But still, it is very important for small and medium entrepreneurship or business thing. The main objective is innovation, performance, engagement, and market reach. The objective for it was analyzing DEI and performance in global industry, how it affect the industries, finding the frameworks, examining the challenges, and exploring the sector regional wise and overall work. This is the history, like from where to where it has been changes, like what it changed through this strategy. There are diversities in many areas like gender, race, culture, region, and many more. Equality we find in fair hiring, pay transparency, supporting underrepresented groups, and every stuff. Inclusion is safety for the background like belongings, leaderships, and employee resource group. The next goes like the sector analysis, that is what it leads to the different sectors in the industry. Like tech, it performs the mentorship, it equally gives the opportunity for mentorship, higher innovation, the profitability. In healthcare, it gives like diversity for improving the patient's outcome. Financially, it provides the cultural shift, better returns. In manufacturing industry, it provides higher safety and innovation. The overall regional approach was like European comparisons, Asia cultural adaptation, emerging markets, education, social economic inclusion. This is the industry specific outcome, like what it shows. Here is the graph, what it definitely shows. Uh, and it provides like technology to increment of 21% of profit, 35% of innovation. In healthcare, 12% of patient satisfaction. Somewhat negative points were also there, like medical errors. Financially, it was growth for like 23% of client satisfaction. Manufacturing was 16% safety and 22% innovation. The data driven strategy was employee surveys, AI, analytical dashboards, equity, public salary bonds, and many more. Implementation recommendations were like executive pay to DEI, quarterly DEI reports, leadership training, recognition programs, cultural adaptation, and local partnership. Innovations and future trend through this is DEI drives innovation and engagement more for everyone. AI for bias reduction, sentiment analysis, remote work opens new diversity avenues, and all. Conclusion for this topic or for my paper or this PPT is it provides an advantage for for businesses, success enabler, leadership, accountability, tech, culture, sustainability programs, and more. Drives the leadership, accountability, cultural adaptation, ethical tech use. Future research helps in growth of small and medium enterprises, cultural models, ethical tech, and long-term DI impacts. Thank you. Any questions?
Thank you for your presentation, ma'am. Are there any questions?
What are your future work? How will you proceed in this?
Sorry, I can't hear you properly.
What will be your future direction? How will you proceed?
In this, the proceeding for the higher is like taking a survey and explaining, getting information about have this actually like implemented in like vast place, like for more industries, or like for everywhere how it is being spreaded and where it is being really implicable.
Yes, you have to choose certain specific domain for it, right?
Yeah.
Then you need to construct the idea behind it. You have to choose certain parameters or factors that you need to consider. Because as such, the domain is widened.
Yes.
Are you getting my point?
Yes, ma'am.
Overall, the idea is good, but just make a note of it.
Yeah, ma'am. Sure. Thank you. Anything else?
No, that's from my side. Thank you and all
Thank
the
you,
best.
ma'am. Thank you so much, ma'am.
Do we have any other question? Moving on to the next presenter, I would like to call again Sir Anurag Agarwal to present his paper on the title Towards Smarter Diagnosis, a survey of CNN in breast cancer detection. Do we have you here with us, sir? Do we have anyone else from the team with us? Since there's no response, we'll be moving forward with the session. This brings us to the end of the session. I sincerely thank our authors for their excellent presentations and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for supporting this fourth version and all the previous three versions of the conference. We'll be happy to have you in the fifth version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ISBM 2025. I would also like to thank both of our session chairs, Dr. Dushyant Singh Razor and Dr. Ruchi Nanda, for chairing this session.
Thank
A
you.
token,
Thank you so much, Ashutosh.
thank you. Token of appreciation to both the chairs on behalf of the team ICT4SD, ISBM 2025 and Global Knowledge Research Foundation. I request both the chairs to say a few words to your participants.
It was a wonderful session. And I'm sure that all the participants must have got certain different ideas how they can do their research and how they can, take it forward, how even the scholar can go for review papers also, because some of the papers were related to review and research studies. So I think this session has benefited all of us. And I congratulate GR team for organizing such conferences from time to time. And thank you so much for inviting me. Thank you.
Thank you, ma'am. So, would you like to say something? It's all right. Just before we end the session, I request you all to kindly switch on your camera for a quick snapshot of the virtual conference. Thank you, everyone. Thank you for joining us today.